Geometry section 4-5 continues with the shortcuts that we had. So if you remember what we had, our shortcuts total as review was that we had side, 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 and side, angle, side. Well, now they're giving us two more. We have angle, side, angle, so two angles and a side that's included, or it's also two angles and a side, but this one is a non-included side. So what it means by included is means the two angles enclose that side, but this one is the two angles are here and then there's one side that's off. So if I can prove one of these sets, okay, then I can add to this. So now instead of 3, I have 4. I can do angle, side, angle, or I can do angle, angle, side. Right? So those become my options. And it's same as what you've dealt with in sections 4-4. You're going to be dealing with proofs, but now you have more options on how to do it. So let's do an example. Please don't forget to pause and write it down, and as well as do vocabulary. So this is our one and only example. Okay. So it's asking us to write a proof, okay? But this is the thing. What it's asking us to do is to not prove two triangles are congruent. So remember in the last section, it's asking us to prove two triangles are congruent, but in fact, it's asking us to prove two sides are congruent. So not only can you use, like in the last section, you dealt with proving two triangles that are congruent, but once you prove that two triangles are congruent, then all their parts and all their angles are congruent. So what we're going to aim to do is to prove the triangles that have this are congruent, so that we can say that these sides are equal. So we're going to take, if you're confused, it's okay, we'll take it step by step. So let's find LN and MN first. So here's LN and MN. So you see, this is the two triangles we're going to try to prove congruent. We're going to try to prove, this is J and M. Okay, this one right here. You see? And then the other side. So it's K LN. So we're trying to prove that these are congruent. The way they put it, okay, the way that they put it allows us to find if angles or whatnot are congruent. So let's start with what we always start with, and that's the given. So angle NKL is equal to angle NJM. Okay, so angle NKL, so this angle is equal to NJM. So NJM is equal to this angle. Okay, and this is because our given. Right? So from here, our next one that's given is KL is equal to JM. So this is telling us that side KL right here is equal to JM. So this is equal to this. So with just our given, let's see what we have so far. Again, our options are side, 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 angle, side, angle, side, angle, or angle, angle, side. So here are our shortcuts, so we don't have to figure out all. So far, we have an angle, right? So one of these. So that means we no longer are going to use this. So we're using the process of elimination, as you can see. So because they give us an angle for us, I know I'm not going to use the very first one. And the next one gives us a side. So here's a side, and here's a side. So we still have three options. Either I'm using, this one is a non-included side, this is an included, either I find another angle or another side. Okay? Just like we did in the last section, please make sure to see if they share anything. Because we've had in the last section that they shared a lot of sides. In this case, you share an angle. So can you locate the angle that they share? Well, in this case right here, J and M, and LKN. So this angle, they both share. So I know that this equals this, okay? And that again is called the reflexive, remember? So angle N equals angle N, and because angle N is only one angle, it doesn't share anything, I can just say angle N. This is reflexive, okay? Because it equals each other, itself. So this is another angle. So because this is another side here, I can cross that out. Now I have to decide, is it an including side or is it a not including side? So in this one, it has two angles, and if it was included, then it would be this one that's equal, but it's not, so it's a non-included side. So this one is an included side, so we're going to choose the non-included side. So our last step tells us, not our last step, it tells us that our triangle JNM equals triangle KNL. Make sure to name it correctly. This is because of AAS. Now, I've proven these triangles congruent, but it's not asking me to prove that they're congruent. It's asking me, in fact, to prove these specific sides are congruent. But now that I've proved these triangles congruent, I can now assume everything else is congruent because I've used a shortcut. So with that, angle L is the last one, is also equal to angle M. So you see this is 2 to 3, this is 2 to 3. So this is telling me that this side is equal to this side. This is 1 and 2, 1 and 2. So this side, 2, 3, is equal to this side. All because of this. And the reason I can state that is in the very first section is it the very first section? But it's a new section, one of the sections in chapter 4, called CPCTC. Corresponding parts of congruent triangles are congruent. It's one of your key concepts. What that basically means is that once you prove these triangles are congruent, then their corresponding parts are also congruent. So my last step was to tell you that LN is equal to MN because of this CPCTC. Corresponding parts of congruent triangles are congruent. Once we prove these triangles are congruent, then everything else, all the other corresponding parts are congruent, and that's what allowed me to do this. And because of this, this equals my last step, therefore I'm done. Alright, so go ahead and try this, page 238, number 2, and I will see you in class.